Hello, hi. Welcome to the new video. Here in this particular video, I will be sharing one of the job description and a preparation questions and answers. Okay, so it is a kind of interview preparation video. So you can consider this particular video along with the questions and answers if you are preparing for a DevOps or DevSecOps relevant roles. And these are the questions I've framed like there is a experience like 2 to 4 years in between. Okay, so I will be going through the category of questions and also the JD first. So if you see here, the company was Sonata. It was for the role of DevSecOps they are looking for, and the reason like why I chose this particular JD was I have received a like interview call for this, and as a part of preparation, it's kind of a preparation for me also before attending the interview. And if any update on the interview, I will keep posted. And coming to the job description, they are mandatorily looking for this particular skill set: IAM, networking, CI/CD, cloud formation, OpenTofu, especially Docker, Kubernetes, EKS, and then GitLab security scanning. And these are the requirements. So 2+ years of hands-on experience with a cloud formation. AWS was the preferred cloud, and CI/CD pipeline expertise, IAC with cloud formation, OpenTofu, and similar tools like Terraform. And there are some advanced understanding on cloud security principles they are expecting, and are the scanning tools that comes under the SAST category, DAST category, SCA category, container scanning, as well as secret detection like GitLeaks, GitGuardian, and that like that expertise in integrating those tools and using those tools like more than 1+ years of experience, and also expecting a good knowledge on Docker, Kubernetes, IAM, AWS, SDLC principles. And yeah, these are the things they are looking for, and these are some nice to have skills, certifications, some compliance related, and some policy as a code like OPA, policy gatekeeper, Sentinel, AWS config roles like this. So here is the responsibilities where you will be primarily involved in design, implementation, and maintenance of secure CI/CD pipelines for cloud-native workloads. And you need to responsible for embedding the security controls into the infrastructure as a code and deployment the workflows, integrate the scanning and testing into the build pipelines. And yeah, these are the primarily responsibilities of a DevSecOps tools. And one more thing I can say, if you see here the responsibilities, this is how you also need to frame your day-to-day activities, or what exactly the technical activities you are doing in your organization if they ask. Okay, so that will this is how exactly in the proper structure manner they have framed. So likewise you also need to frame in such a technical in-depth, as well as what exactly the task covering here. Okay, and moving to the questions, like I have categorized these a skill set into some categories and media questions. First, with respect to the AWS cloud security, and later GitLab CI/CD and security integrations, and then infrastructure as a code with respect to cloud formation and OpenTofu also I have covered, and policy as a code and compliance perspective. Then containerization and orchestration with respect to Docker, Kubernetes, and EKS. Later, monitoring and logging also includes the incident response. And then finally, the advanced DevSecOps strategies and automation questions. Okay. So yeah, without further ado, let's have a discussion. And whatever I was presenting on the screen, I will be sharing entirely in the in the video description. You can refer it, and you can use that for your preparation too. Okay, it is a GitHub repository, whatever I was presenting. And the first question here was like, what is the core concepts of AWS IAM policy, and how do they enforce the principles of least privileges? So here, the IAM policy includes mostly there is a resources, there is a conditions, there is a actions and efforts. Okay, so in IAM policy, it is basically a JSON document, so that basically defines the permissions. So it consists of effect, that means whether it need to allow or denies the specific access. Okay, basically that statement defines that. And action, it is the specific AWS operation, like AWS S3 get objects or uh, put objects, like that. Okay, basically what actions so that AWS operation can do. Okay, and then the resource where it specifies the a specific AWS object, the action pipelines. Let's say example, this particular thing. Okay, so what exactly the uh, what exactly that specific action does. And there is a one condition, like there is a principle of constraints, sorry, optional constraints. So that includes the IP addresses, time of the day, and MFA presence, basically providing a least privilege enforcement. Uh, this particular condition will be used. So instead of using the star, that means providing a wildcard access. So we need to specify specific actions what they can be allowed to do. Okay, what exactly necessary. And moving further, like the second question was, how does the AWS Identity Center, formerly the SSO, we can say, differ from the traditional IAM user management for workspace access? So here, IAM users are long-term credentials which was created within the AWS environment, and they typically involve the username, passwords, and the combination of access keys and secret keys. You must manually manage those for recreation and rotation. And coming to the Identity Center, AWS Identity Center, it is like a centralized identity management. That service allows the workforce users to sign in by using the existing corporate credentials. By using these are the SAML was the protocol, and OIDC was the protocol, and SSO was the one of the protocol. So these are SSO protocols. So it provides a temporary short-lived section credentials for the AWS STS rather than long-lived credentials. So this basically centralizes the access management, and it removes the need to create an individual IAM users for every employee. So whenever the large organizations work in this way only. Okay, why? Because there is a lot of users, right? Some hundreds, thousands of users or developers. So instead of manually creating a users and ascending to them, we need to configure the SSO through that. And moving further, like what is the architectural design of a secure VPC, which is a virtual private cloud, regarding the public and the private subnets, and how are the NACLs differs from the security group. So there are two questions here. So coming to the architectural design with respect to the secure VPC. Here, a secure VPC separates the traffic between the public subnet and the private subnet. So here, the public subnet, it uses it routes the traffic to an internet gateway, and the private subnet, there is no direct route to the internet. Typically, it uses a NAT gateway. Okay, so here the database and application servers reside within the private subnet to prevent the direct internet access. And coming to the difference between the NAT gateway and security groups, here NJCL, which is not a NAT gateway, it is NJCLs. NJCLs is basically network access control units, or it operates at the subnet level, and they are the stateless. That means rules must be defined for both the inbound as well as outbound traffic, and it was evaluated first. Okay, and coming to the security groups, where it operates at the instance level, which is ENI level. Okay, and they are stateful. That means the return traffic is automatically allowed, both inbound and outbound traffic. Okay, and are evaluated after the NJCLs. Okay, and first the NJCLs are evaluated. Later, the security groups are evaluated. And moving further question, like how a short-lived credentials generated and managed for CI/CD pipelines by using the AWS STS. STS is basically security token service. So, or the OIDC. OIDC is also one of the protocol, or OpenID Connect we can say. So let's discuss both the OIDC as well as STS. Here, OIDC refers to the OpenID Connect, as I said, and the CI/CD provider, that might be Jenkins or GitLab, it generates a JSON Web Token, we can say JWT token. So the pipeline will exchange this particular JWT token with the AWS STS, which is Security Token Service, by using this particular API call. Okay, so this is the API call here. The call was assume role with identity, web identity. Okay, so coming to the STS, where AWS will validate that particular token against the configured OIDC, OpenID Connect, and OpenID Connect provider, and it will returns a temporary credentials, that might be access key ID or secret key, access key, and session tokens like this. So these particular credentials are valid for a long term, long for short durations, example whenever or like that, and that will automatically expire after that particular specific time. And also removing the need to store a long-term secrets in the CI/CD configurations. So this is how exactly the short-lived credentials are generated and managed within the CI/CD pipelines. And moving further, like what is the difference between the AWS secrets manager and parameter store, and when should each be used for storing the sensitive data? So here, the AWS Secret Manager was the which was optimized for storing the secrets like database credentials and API keys or API tokens. So it includes the features for automatic rotation of credentials and secrets, and at a defined like schedules. Basically, we are going to define that schedule at 3 months or 1 month, or like however we need to rotate those particular keys. So it is slightly more expensive. Okay, why? Because it is automatically rotating the passwords. And coming to the parameter store, where it is optimized for configuration data and strings. So it has a standard type, which is free type, and the advanced type. So it can store the secure strings, which is in the encrypted format, but it does not natively manage the automatic rotation logic without a custom Lambda functions. So here, coming to the use case, we use the secret manager for secrets requires the frequent rotation, and we use the parameter store for configuration data, and or else secrets where the cost is a major constraint and rotation is not required that frequent. So in that case, we can go with the parameter store. And moving further, like how does the AWS KMS, which is key management service, manage the encryption keys, and what is the difference between the custom managed keys, which is CMK, and AWS managed keys? So here, the KMS, which is a key management service, is a managed service that creates as well as controls the cryptographic keys which was used to encrypt the data. Okay, and coming to the custom managed keys and AWS managed keys. So here, CMK, which is custom managed keys. So keys will created and fully controlled by the user itself. So you defined the key policy, and you are going to specify enable or disable the key, and manage the rotation also manually by the user only. So you pay only monthly fee for these particular keys. And coming to the AWS managed keys, so here the keys are created and managed by the AWS services like AWS EBS. So you cannot manage the key policy, or else you cannot disable them also, but they are free to use, and they provide a less granular control. So that is the AWS managed keys and customer managed keys. And moving further, the seventh question, like what are the mechanisms to enforce the network segmentation within the AWS? There is a segmentations like VPC peering, transit gateway, private link, like that. So let's discuss each and every one. VPC peering basically to connect. It basically connects the two VPCs via the direct network route, and they must have a non-overlapping CIDR blocks. So here the traffic will allows here the traffic will flows privately between them. And coming to the transit gateway, where it acts like a cloud router, so it connects a thousands of VPCs and the on-premise network through a central hub, which is simplifying network topology. For simplifying network topology, we are going to use the transit gateway. And coming to the AWS private key, so basically to expose the specific service like API or the load balancer privately via the private IP address within your VPC. So it basically allows the services to access uh, like without traversing the public internet or using a NAT gateways. Okay, so that is the like basically mechanisms to enforce the network segmentation within the AWS. And coming to the another last question with respect to the AWS, how does the AWS S3 bucket policy differ from IAM user policy in terms of access control? Here, let's discuss both. IAM user policy, it is an identity-based policy which was attached to an user or else the role. So it defines like what exactly that identity can do. Let's say user A can list the objects. So this is the IAM user policy. And coming to the S3 bucket policy, so here it is a resource-based policy where it was attached to the S3 bucket itself. So it defines who can access this particular specific bucket. So let's say this particular bucket will allows user A to list the objects. So those are resource-based policies. And the key difference here lies is that the bucket policy will travels within the with the particular resource, and even let's say if the user has no IAM policy, let's say if that particular bucket policy allows the user account ID, they can access the access will be granted for that particular user. Okay, so this is how exactly the difference between the IAM user policy and S3 bucket policy. And coming to the another category of questions, which is with respect to the GitLab CI/CD and security integration related questions. So here the first question was, what is the structure of GitLab CI/CD pipeline? Basically the GitLab -ci.yaml file, and how do the stages or jobs or scripts related to each other. Okay, and here the pipeline is basically defined in the YAML file. There are stages, jobs, and scripts. In the stages, we are going to define what exactly the execution order, like build, later test, later we need to deploy, like that. So here the jobs within the build stage must finish before it was going to the further test or deploy stage. Okay, and coming to the jobs, where we are going to specify the exact specific task to run. Let's say if you in the each job it runs on a runner. Okay, basically, so runner is the target executor or worker node, we can say. Okay, so here the jobs within the same stage run in the parallelly also. Okay, if let's say multiple scanning tools are there, SCA, SASH, like that. Okay, so both can be run in simultaneously by using this jobs. Within that jobs there is a steps. Okay, those steps are SCA and SASH. And coming to the scripts, where those are the shell commands were executed by that particular job. As I said, within the jobs there is some scripts, commands basically. Let's say so to install some packages or to perform some code scanning or some activity. Okay, so that can be achieved with the particular stage. And moving further, like how is the GitLab SAST, which is static application security testing, configured and integrated into the pipeline workflow? So here the GitLab has a one feature which we can say template. Okay, GitLab provides a dedicated own template. So it includes this particular this is the default template. Okay, so we are going to include that in our YAML file. So when the pipeline runs, the GitLab uses the default analyzers. I mean, there is a multiple analyzers. Basically, the analyzers are end tools, which was used to perform the SAST scan. So, and then it will scans the source code and identifies the security vulnerabilities, and the results will appear as a security report in the merge request, and the developers or the target team can view that and mitigate the vulnerabilities. And moving to the 11th question, like what is the difference between the GitLab container scanning and dependency scanning? Dependency scanning, which is software composition analysis. Container scanning, which is basically the image scanning, Docker image scanning. Here, let's discuss both. Here, the container scanning, which scans the container images, which is basically the Docker images. Let's say if there is any vulnerable packages out there, or it basically scans for the vulnerabilities in OS level. Okay, container scanning. And coming to the dependency scanning, which scans the application dependencies, and it scans on the application level, and it scans for the vulnerable packages. Okay, let's say in pom.xml there is a vulnerable package was utilized, so that is particularly identified in the dependency scanning. Okay, and for both the vulnerabilities are listed to the developer team, and they will work on that. And moving to the another question, like how does the GitLab secret detection work within the pipeline, and where does it scan for the credentials? Here, basically, GitLab secret detection uses the tools like Git leaks, Git Guardian, like that. So it includes, it is included via the secret detection template. So how the SAST scan source code scan template it is there. Likewise, there is a secret detection template, and it scans the repository files in that particular pipeline, including the previous commit history also, and looks for the patterns if there is any AWS access key or API key or private keys, and it attempts to detect those particular secrets even if they are committed to that particular repository in the past also. So each and every commit history it is going to scan, and it will find those particular secret, and it will list it down. And moving further, the 13th question was how the DAST, which is dynamic application security testing, integrated into the GitLab pipeline, and what is the infrastructure which was required for this. So here, a DAST requires a running application to scan, and it includes a DAST template, how the SAST SCA template is there, secret detection template is there, like which we are going to use the DAST template. Here, the infrastructure requirements are you must deploy that particular application in your dynamic environment. That means in a running environment like a staging or dev environment like that. Okay, and do not test any application in the production. That is very critical. Okay, and we are going to provide a dashed website variable that basically includes the end target URL to scan, and here the dashed will basically analyzes the HTTP requests to that particular URL and finds the vulnerabilities, like is there any SQL injection or cross-site scripting, like something like that. Okay, there are tools like dependency check has that attack proxy, or 45 web inspect it is there, checkmarks it is there, and yeah, there are quite many tools. Okay, so and moving further, the 14th question was what are the GitLab CI/CD variables and how are they masked to prevent the secret leakage within the logs. So here the variables are the key value pairs which was configured within the GitLab UI, basically, or we can configure that in the YAML file also, which is a let's say if we have a non-sensitive data, we can configure that within the YAML file. If it is some sensitive data or any passwords or secrets, then we can configure within the GitLab UI. Okay, and here they act as the environment variables or in that particular job. And coming to the masking, how exactly it works was within the GitLab UI, which is user interface, there is a there is a option to mark that particular what we can say key value pair has a masked variable. Okay, so if you check that, the GitLab then replaces that particular variable value with a masked. Okay, in the job logs also it won't appear. So And moving further, we'll be discussing on 15th question, how do the GitLab run? GitLab rules. There are rules like only, except, when, like that, control the execution flow. So here these particular rules. Let's define. Let's go with the one by one rule. Basically, these rules are used to control the pipeline execution flow. Okay. So coming to the only and except. So whenever we are going to, uh, let's say, when a job is added to that particular pipeline based upon the branch names and the tags, or else the variables also, and only we can specify this particular branch name, like that. Okay. Or if that particular branch comes, then only that particular pipeline will be triggered. And there is a rule like when. Okay. Basically, when control, it is also one of the condition for job execution. Let's say on success, on failure, or some manual, or always. So these are the some control execution conditions. On success, that means it runs if the previous stage was succeeded, and on failure means it runs if the previous stage was failed only, and manual means it requires a manual intervention in the UI to start, especially for deployments we can use this. And always there is a condition where it with respect to previous results won't consider, regardless of the previous stage status, it will automatically run. Okay, that is the always. So these are the conditions, basically the rules which we are going to use to control the pipeline execution flow. Okay. And moving to the 16th question, how is the OIDC, which is OpenID Connect, already we have discussed it in the AWS related questions, configured between the GitLab and AWS to allow the secure pipeline authentication without a long-lived credentials. So here, that means we need to use the SSO to access the GitLab and AWS. Here, the process includes, first, in the AWS, we need to create a AWS identity provider in OpenID, within the AWS, we need to create a OIDC, OpenID Connect identity provider in IAM by using the GitLab URL. And we need to create an IAM role with a trust policy allowing GitLab provider to assume it. And in the GitLab, what we need to do was we need to configure the CI/CD variable like AWS role ARN, like that. And here it looks like this. Okay. And then in the pipeline, where we need to GitLab will generate a JWT token, and the AWS SDK in the particular job, it uses the token to call the STS, and with the API call assume role with web identity, and it basically retrieves the temporary AWS credentials. And this is how exactly the OpenID Connect is used to configure between the GitLab and the AWS. And moving to the further question, 17th question. What are the GitLab pipeline templates, and how do they promote the reusability and standardization across the projects? Here, the GitLab templates are the reusable YAML snippets or scripts, which was stored in the GitLab-ci.yaml file. Okay, so that includes the using the include or extends, like that, or in a separate repository also we are storing basically for reusable templates. And coming to the promoting the reusability, instead of writing the build steps for a Java application 50 times, so let's say if we have a 50 multiple applications, so instead of writing those manually 50 times, we write at once in a template, and all those particular Java projects simply include this particular template. And if you need to update the Java version or add a security scanning, or you need to update that particular template file only, and the projects will automatically inherit those changes automatically. Okay, so this is how exactly the GitLab pipeline template uh, promotes the reusability. And moving further, how do protected branches and status checks enforce the security guardrails before merging the code? So here, the protected branches basically restrict who can push the code changes, or else merge the merge requests to specific branches like main or production, like that. Here, status check basically includes when your pipeline runs, it generates a status checks. So you can configure uh, a protected branch to require all checks to pass before merge button is enabled. So this basically ensures no code can be merged into the main or production unless all the security scanning was done and passed through that particular scanning, all the scanners. Okay, and moving further, what is the function of a GitLab runner? What is the function of GitLab runner? Shared, specific. How are they secured? So here, basically the runners are the end servers that execute that particular job. Here, coming to the shared runner, where it provides by the GitLab itself, and they execute the jobs for any public projects or any private projects within minutes. So they are shared across the users. Multiple users can use that particular runner. And coming to the specific runner, where it was specifically registered for those specific project, and it can be used only for that particular project. And coming to the security perspective, here the runner should run in a containerized environment by using Docker executors, basically to isolate those jobs. And with respect to the self-hosted runners, we can run them in a private network and use those tags to ensure there is a sensitive deployment. Jobs only run on a trusted as well as secure runners, not a public shared ones. So this is exactly the function of GitLab runners, and how they are secured, basically these two runners. And coming to the IAC infrastructure as a code, we'll be covering the questions with respect to the cloud formation and OpenTofu. So here, with respect to the cloud formation, like what exactly the architecture as well as syntax difference makes difference between the cloud formation and OpenTofu. So these are OpenTofu was one of the open source tool, and cloud formation was the AWS managed service. And here the cloud formation uses the JSON or else the YAML templates, and OpenTofu uses the HCL, which is HashiCorp configuration language. So it was specifically designed for the infrastructure as a code, and it is often more considered for more reusable modules. And coming to the architecture wise, here the cloud formation is a AWS specific. It is managed by the AWS service, and it is a managed AWS service, and it was managed by the AWS state. Here the AWS manages this particular state and provisioning, engine, everything. And OpenTofu is a cloud agnostic, and it is it basically uses the providers to interact with the cloud services like AWS, Azure, or something like that. And you must manage this backend state by yourself. That means user. And we need to install this locally to run the OpenTofu binary. Okay. And moving further, how the state management handled within the OpenTofu, and why the remote state locking mechanism is essential for teams whenever we are working with the teams. So here, state management, OpenTofu records the mapping between your code as well as the real world resource in the state file. That means in the .tf state. with a remote state logging mechanism. Okay, so why exactly the remote state logging mechanism requires was whenever we are working with a teams, here storing a file locally is very much impossible, and here the remote state will stores that particular file in a shared backend mechanism like AWS S3. And coming to the locking mechanism, when a user runs a tofu apply, okay, here the lock is placed on the state file, and it prevents other users from running tofu apply in the same time with the same file. Okay, so it basically prevents the corruption, file corruption, and it ensures the state will remain consistent and valid across the environments. Okay, and moving further, like what exactly the cloud formation stacks, what are the cloud formation stacks, and how does the stack sets enable the deployment across the multiple accounts or regions? So here basically the stack, a stack is a collection of AWS resources that are managed within a single unit. So here all resources in the stack are created, updated, and deleted together at a time. We cannot manage them individually. Here is stack set, which basically extends the concept of a stack to enable the deployment across the multiple AWS accounts and regions with a single operation. So you're going to define the stack template once, and the stack setup will pushes it to the target accounts or target regions automatically, and it handles the orchestration of creating a stacks in those different targets. So this is the cloud formation stacks. And moving further, how are the modules used within the OpenTofu to organize the reusable infrastructure as a code? So here, modules are the constraints for multiple resources. So, sorry, modules are the containers for the multiple resources that user together, and instead of writing the same VPC configurations or subnet or route table, everything each and every time and each and every project, we write a single time in a specific module directory, and that module will accept the input variable, uh, and basically input variable will be CIDR block, and the output variable, and outputs the output variable, which is like VPC ID. So in your root configuration, you simply call that particular module with a specific variable. So basically this promotes the standardization, and reduces the code duplication across the projects whenever we are working with a team. And moving further, like what exactly makes the difference? What is the drift detection? How the cloud formation or else the OpenTofu will handle this particular thing? Basically, the drift is something like if someone made a changes in the cloud UI or else through the command line, and the resources which there is in the state file, those are not same. Okay, that time a, a drift was detected. Okay, so in simple process, drift detection is the process of detecting the changes made to infrastructure outside of the IIC tools, like say example manually through the console or through the command line interface or something like this. And coming to the how it was handling through this OpenTofu or cloud formation. In the cloud formation, we are going to enable the drift detection on the stack. So the cloud formation will compare that particular actual configuration of the resources against the template, and it reports if there is any drift was found. And coming to the OpenTofu, like where we are going to run a command which is tofu plan and refresh only. So basically this will updates the state file with the real world values without making the changes or highlighting in the plan what exactly the changes or what exactly it was drifted. So and then you are going to reapply the changes. You are going to reapply the configuration to bring the resources back to the desired state. So this is how exactly the OpenTofu as well as the CloudFormation will handle the drift detection in the cloud environment. And moving further, like how the security scanning that might be CheckOV, DevSec are integrated into the IAC uh, development lifecycle, into the development lifecycle. Okay, so here these particular scannings can be integrated into the CI/CD pipeline and are pre-commit hooks. That means whenever a commit was triggered, then it will automatically perform that particular scan. Here through the help of a pre-commit, the developers can run that locally. Check OV -d space dot. That means whatever the IAC files located in the current directory, with the help of check OV tool, it was going to perform the IAC scan. Okay, before pushing the code into the repository also. And in the pipeline, where the pipeline will runs the scanner against the CloudFormation templates or OpenTofu files or any Terraform files, and let's say if the scanner finds any security vulnerabilities issues, and let's say open security group or unencrypted S3 bucket, here the pipeline will fail immediately, and it will enforces the security before even the infrastructure was deployed into the target environment. So moving further, like what exactly the change sets in CloudFormation and how do they assist in safe infrastructure updates? Here the change sets is a summary of what exactly the changes that was performed in the CloudFormation that will make to the stack if you execute it. Okay, so instead of executing the template directly, you create a change set first, then the CloudFormation compares that with a new template with a current stack, and that will list exactly what will be added or what is modified or what is deleted, and then you are going to review this particular list to ensure the changes are expected and safe. And once it was approved, you execute the change set to apply the updates to the target. And moving to the further category of questions, which is policy as a code compliance, policy as a code and compliance. These are nice to have skill. Okay, so I will be covering quickly like what is the concept of policy as a code and how does it differ from traditional compliance auditing. Here, policy as a code involves the defining the security and compliance policies in a mission readable code, like Sentinel was the one of the tool, and there is a tool called Cloud Custodian and Rico, where basically automatically it is used for automatically enforcing them via the automated tools. And coming to the difference, where in the traditional auditing, where the manual auditing will be done usually in a specific period or quarterly or yearly ones like that, and it finds the violations which already occurred. Okay, and policy as a code, which it is a continuous like auditing process, which was helps to detect if there is any misconfigurations with respect to the security, and before even it was going to occur, it will be detected. Okay, and it will block if there is any non-compliance resources. So that is the what exactly makes the difference between the traditional compliance auditing and policy as a code compliance auditing. And a question with respect to the OPA, which is Open Policy Agent, how exactly it works and what is the purpose of RECO language. Here, OPA is the general purpose policy agent, where it decouples the policy from the particular service, and the workflow includes a system, OPA evaluation, and OPA returns a decision. So here, the system means what exactly the input was sent. Okay, it is a set of JSON input with a open policy agent configurations. So and the open policy agent will evaluate that particular inputs. Okay, sorry, this was the, here in the first step, the system sends a JSON input to the OPA. Okay, let's say example, user A wants to create a pod, and then here the OPA, what it does was it evaluates the input against the policies within that particular, within the rego, and the OPA will return the decision allow or deny. And here rego was the a declarative query language which was used to write the policy logic in OPA. Okay, open policy agent, how the JSON or YAML configuration is there. Likewise, for writing the policy configurations, Rego was the language. Okay, and moving to the other, what is the role of Sentinel, especially in the Terraform or enterprise context compared to the OPA? Here, the Sentinel is the HashiCorp's policy as a code framework, which was primarily used within the Terraform cloud or enterprise grades. And coming to the comparison, OPA, which is open source and language agnostic and widely used with respect to the Kubernetes and cloud native environments. And coming to the Sentinel, which was which was proprietary to the HashiCorp and which was integrated deeply into the Terraform workflows, and it uses a similar logic like Sentinel language, but it uses a designed, but it is very much especially designed to govern the Terraform plans and state files. So that is exactly the Sentinel as well as OPA comparison. Okay. And moving further, like how do the AWS config rules evaluate the resource configuration for compliance like SOC 2 NASD? So here, AWS configure will continuously monitors and records the configuration of the AWS resources, and there is a config rules. Basically, you define a rule, or else you use a managed rules also based upon the compliance standards, like what exactly the standards you need to meet, like SOC 2 or NASD. And the process includes when a resource was configured. When resource configuration changes, AWS config will automatically trigger the associated rule. So here the rule will evaluate the resource, which was basically properties. It will evaluate those properties against the defined logic. So let's say example is encryption enabled, so it will check that. So the resources is tagged as compliant or non-compliant based upon the policy we have set, and it will trigger the action or remediation step also automatically. So this is how exactly the AWS config rules evaluated the resource configuration for compliance perspective. And there is a question with respect to the CIS benchmarks, like how are the CIS benchmarks automated and ensured using the cloud native tools or open source scanners. Here the CIS benchmarks are the perspective security configuration guidelines. Coming to the automation, how it will be worked, there is a AWS Security Hub and open source scanners. Coming to the AWS Security Hub, it will integrates with the AWS config to check the resource against the CIS benchmark, CIS AWS Foundation benchmarks, and it will generate the compliance scores. And coming to the open source scanners, where the tools like Scout Sort, InSpec, okay, that will run periodically, and they query the cloud API, and that will check the configurations against the CIS checklist, and that will generate a report of failed controls. So this is how exactly the CIS benchmarks automated and enforced a single cloud native tools or open source scanners enabled. And moving to the another category of questions with respect to the containerization and orchestration, like what are the security benefits of using multi-stage builds within your Docker? So here, Multi-stage Docker basically means using a multiple from commands, from instructions in a single Docker file. Coming to the security benefits, basically the build stage can use a heavy image containing a multiple dependencies or installers, build tools, everything. And then in the final stage, they copies only the compiled binary artifact into the minimal or uh, stripped down base image, all fine. Maybe in the first stage they might use a high weight image, and in the second image, sorry, in the second what we can say, multi-stage, right? In the second stage we are going to use the lightweight image. So basically this will helps to remove the uh, what we can say, all the undependent tools or any scanners, not yet scanners. It is basically compilers or any dependency packages and libraries, and obviously it will reduces the uh, attack surface, and it reduces the significant risk. Okay. And moving further, how does the EKS, which is Elastic Kubernetes Service, differ from the self-managed Kubernetes in terms of control plane responsibility? Here, coming to the self-managed, so you are the one responsible for provisioning the master node. That includes all the API server, etcd scheduler, and you are responsible for managing, upgrading, patching, and high availability maintenance, everything. And coming to the KMS, which is AWS managed, and AWS will manages the control plane across the multiple availability zones, and AWS also will handles the patches, upgrades, high availability of that particular master nodes. And as a user, you are the only one responsible for managing the worker nodes. Okay, and whatever the applications running on the worker nodes that you need to manage, basically worker nodes and runtime. Okay, so that is exactly makes the difference between the self-managed and KMS. Kubernetes management service. Okay, and moving to the another question, like what are the Kubernetes network policies, and how do they enforce the micro segmentation between the pods? So here the network policies are the rules that control how pods can communicate each other and other network endpoints. So here, coming to the enforcement, by default the pods can communicate with all other pods. Here the network policies will allows you to define basically the whitelist the roles. For example, if you specify that pod A can only accept the traffic from pod B, okay, and reject everything else. So this can be creates a micro segmentation and limiting the lateral movement of attackers. Let's say if one pod was compromised, the lateral attack surface will be reduced, and yeah, this is how exactly the micro segmentation is enabled. And moving further, how does the Kubernetes RBAC, which is role-based access controls, work, and what is the difference between the role and the cluster role? Here, RBAC is the one which regulates who can do what and on that particular cluster by using your roles and role bindings. Coming to the role and cluster role basically defines the permissions, list the pods with a specific namespace, within a specific namespace. Okay, roles are within a specific namespace, and cluster roles are uh, is in the cluster level. Okay, so you are going to define the permissions at the cluster level across all the namespaces. If it is role, only in the specific namespace. If it is cluster, if it is cluster role, then across the all namespaces it will come. And let's say if there is any cluster wide resources like nodes or persistent volumes, then cluster roles was the preferred advantages. Okay, And then moving to the another question, what is an admission control in Kubernetes? Example, OPA, gatekeeper, and how does it enforces the security policies? So here, basically, admin controls are the plugins that intercept the requests to the Kubernetes API server before the object is created or updated. And OPA, which is Open Policy Agent Gatekeeper, it uses the OPA policies as the admin controllers. So whenever the developer tries to create a pod, let's say example, with the privileged is true. Okay, so the gatekeeper will intercepts the request. It evaluates the pod, defining against the loaded OPA policies. If the pod violates any of the policy, the gatekeeper will reject it immediately, and it shows a error message as per the policy which we have defined. Okay, and moving further, how are the Docker image scan integrated into the CI/CD pipeline before we are going to deploy into a EKS? So here the integration typically happens after the Docker build step within your pipeline. That means we are going to include the scanner like a Trivi, Aqua, or Snake. Uh, there are multiple scanners, and it basically scans for the OS level vulnerabilities, and we can set up a fail gateway also. Let's say if a pipeline script checks and exit code of that particular scanner is non-zero, then that should fail. Obviously it will fail, and let's say we can set up a failure criteria based upon the severity of the vulnerability also, like high, critical, like that. Okay, and we can block the pipeline also. That means it will stop the pipeline and preventing the vulnerable image being pushed to the Elastic Container Registry or Docker Hub, like whatever the target registry is there. And what is the purpose of Helm charts within the managing Kubernetes deployments, and how the Helm values are secured? Here, the purpose of Helm was Helm is a package manager for Kubernetes. Here, a chart is a collection of pre-configured Kubernetes resources, basically the templates that includes the deployment, services, config maps, and it simplifies the complex deployments. And coming to the securing those values, so here there is a values.yaml file. So it contains the configuration data to secure the sensitive data. We need to we do not to support hardcode the secrets or anything within the YAML file, and we need to use the Helm secrets plugin or some external secret manager, HashiCorp Vault or AWS Secret Manager, like that. And coming to the reference, the Kubernetes secrets will directly into the templates. We can refer this in this way. Example, okay, value from secret key reference. Okay, so basically this will ensure a sensitive data is stored in the encrypted Kubernetes secret store, not in the Helm chart files. And moving further, questions with respect to the monitoring and logging. What is the difference between metrics, logs, and traces? So here, metrics are the numerical data which points a measured over a time. Let's say CPU usage, request latency, error rates. Those will comes under the metrics. And coming to the logs, where these are the distinct records of events or text messages also. It provides a context of a specific details about like what exactly happened. Those are the logs. And coming to the traces, so these are the records of the path a request take through the distributed system. So they track the request as it moves from the service A to a service B to service D. So traces will basically helps to identify the bottlenecks or the failure in a specific translation flow where exactly it was happened. So then how are the CloudWatch logs, insights, or ELK stack used to troubleshoot the security incident? So here, basically the CloudWatch logs or ELK stack, which acts as a search engines for log data. Coming to the process, it includes the injection, querying and analysis. In the injection, where there is a security logs which were sent to the CloudWatch or Elasticsearch, and then querying where we need to during an incident we need to analyze and run the queries to filter a specific events. Let's say, for example, we need to search for cloud trail logs for the console login. Then let's say if the error message showing as failed authentication, with the querying we can achieve that. And coming to the analysis part, where we can identify what exactly the patterns such as spikes in the access denied errors, and is it a single IP address which indicates the brute force attack of unauthorized attempt access. So like that, this CloudWatch and ELK stack inserts will help in troubleshooting the security incidents. And moving further, like what is the standard workflow for incident response in a DevSecOps context? Basically, that includes the detection, containment, education, and recovery. In the detection, with the help of monitoring tools, we trigger a alert based upon the analogy, or based upon the error message, or based upon the severity of that particular incident. Okay, and then containment, where it includes the immediate action to stop the spread of that particular what we can say security breach, and that involves the isolating the affected instances, a quick fix. Okay, and stopping the pipelines to push forward. And education, it involves removing the root, it involves uh, what exactly the root cause. Okay, so what exactly it was removed, and what involved in patching that particular vulnerability. And coming to the recovery, where how the restoring service as well as clean backups and verifying the service is secure or not. So this is the recovery part. And moving further, like how are the alerts are configured for critical security events. So here the alerts are configured by using the event rules and the metric thresholds. Let's say crypto mining, which is based upon the matrix, we configure an alarm of an CPU utilization matrix. It's of an EC2 instance. Let's say if the CPU usage exceeds the 90% for continuously 15 minutes, we need to trigger a SNS notification, and or any other pager duty notification or something like that. And moving further, like coming to the IAM policy change, we use the AWS Cloud Trail with the event bridge, where we can create a role that lists for a specific API call. Like, these are the API calls: attach role policy, puts user policy. Let's say if such event occurs, the event bridge will trigger a Lambda function or sends an SNS notification to your security team immediately. And coming to the another question, what is the purpose of a post-incident review and how does it improve the security posture? Here, a post-incident review is the meeting that will held after the incident resolution was happened. And here, the purpose of this was it is not about blaming about the teams or the persons. It is about further improvements. Okay, so in the post-incident review process includes what exactly the lessons they have learned, and they need to document them, and they need to train the team accordingly, and they need to implement they need to make changes in the process. Basically, they need to go with the playbooks or something, run books or something, and what exactly the action items taken to like fix that particular issue, and is there any gaps in the team that will be discussed. Okay, that is the purpose of post-incident review. And coming to the some advanced questions, how the shift left is implemented in a software development lifecycle to detect the vulnerabilities early. Here, the shift left means moving the security testing to the initial development phase itself, not after the production deployment or something. Okay, that means within the IDE plugin, within the IDE level itself, we need to like integrate the IDE plugins. Based on that, they will perform the scan and they will identify the code level vulnerabilities, and once it was fixed, then only the fixed vulnerable free code by the developer will be pushed into the target GitLab repository. And moving to the another question, what is the strategies for implementing the guardrails within the CI/CD pipelines to prevent the insecure deployments? First thing was follow quality gates, where let's say if the uh, if in the security scanning tools found some critical or high vulnerability, then we need to fail that particular pipeline to not execute. Okay, that is the one. And policy as a good, also one of the thing. Sorry, policy as a good, where it uses your tools like OPA, Open Policy Agent, to validate the Kubernetes manifest and Terraform files and security roles within the cloud environment. And also, as I said, the block for failure whenever the configuration of the critical or severe vulnerability we found. That should fail. Okay, and there is a difference between quality gates and failure criteria. Okay, quality gates is something the pipeline will be divided into a stages, and that stage cannot start unless the previous stage passes all the checks. So that is the quality gate. And failure criteria is something, let's say within that particular one stage there is a scanner, and the scanner is getting severe vulnerability was found. So in that particular case, it should look on that particular vulnerability and should fail the pipeline, or it should fail that particular pipeline build if that happens. So that is the failure criteria or block on failure criteria. And moving to the another question, how does the dependency proxy in GitLab improves the security and speed for package downloading? Okay, here dependency proxy, which sits between the GitLab CI runner and the public package registry. So here speed will be achieved where it stores, proxy caches, it stores the packages locally, and whenever the pipeline runs, it downloads the packages from the local cache only. So it won't go to the public internet directly, and it will obviously reduces the download time. And coming to the security, it acts as a firewall, and it can block the connections to compromised or some malicious upstream packages. So it will basically ensure that the developers only pull from the approved packaged versions only. And moving further, what are the challenges of automated compliance in rapid deployment environment? So here, obviously, there will be a friction between the DevOps and compliance team. Let's say, there is a three main areas, which was a drift in a rapid deployment environment. The infrastructure will changes very rapidly and very consistently, and you need to keep the evidence for each and every security flaw, or all the real-time differences need to be scanned, and you need to have a report of that. And coming to the volume, whenever obviously there will be a multiple accounts or configuration data which is there. So obviously we need to go with respect to the compliance perspective, we need to run all the scans, all the quality gates, whatever it is applicable, that need to be added for that. And coming to the solution, especially with the help of automation, we can achieve some of them. So embedding the compliance checks into the CI/CD pipeline. So every deployment, whatever it is happening, let's say some hundreds of deployments are happening in a day. So through the help of, by integrating the quality compliance within the DevOps pipeline, so that can be achieved. And what is the infrastructure guardrails need to be infrastructure guardrails to prevent the developers from creating a non-compliant resources. So basically, this particular infrastructure guardrail includes the service control policies. So here we are going to apply service control policies or Kubernetes admin controls. So this particular mechanism includes, we need to define your policy where it states, let's say example, S3 bucket cannot be public. So coming to the enforcement, when your developers try to run that particular script to create a S3 bucket, the AWS API or else with the help of Kubernetes API, it will interrupt the request and it will block because it was a guardrail through the policy it was settled, okay, and that API request will be rejected, okay. And moving further, like what is the service mesh, like Istio, in securing, what is the role of service mesh in securing the microservices configuration, basically communication or configuration. Okay, a service mesh is a dedicated infrastructure layer for managing the service-to-service communication. Coming to the security role, which is MTLS, which is mutual TLS. Here, the service mesh will automatically encrypt all the traffic between the service using the TLS configuration, and it also handles a mutual authentication. Where the service A validates the identity of service B by using a certificates before it was talking to it. So that is the mutual TLS, and the zero trust is established. That means this prevents an attackers on the network from intercepting a traffic or impersonating a service, as they would need a valid TLS certificate issued by the mesh, service mesh, like Istio. Okay, and to come into the final question, like how do the chaos engineering practices contribute to improve the system reliability and site security? Basically, chaos engineering was the practice of intentionally doing some security activities, okay, some failure activities. So that will achieve the reliability, where we are going to verify the system automatically, is it recovering automatically in the failover criteria, and it will basically help, I mean, it will help to perform the health checks like that. And coming to the security, where obviously security controls often fail under the stress. Here, the chaos engineering will reveals if encryption keys are rated correctly during the restart, or it basically validates the security posture and helps to refrain against that. So yeah, these are the things I wanted to be discussed in this particular video. And as I said, I will be providing this in the description. Kindly check it out. And all the best for your preparation. And thanks for watching.